Hello guys. I hope you guys doing well. So this is it's the engineering section of my lectures, and this is also ore reserve estimation, iron ore in detail. So today I have to discuss about the borehole data and how we can calculate the ore reserve and from the core sampling of the data. So this is actually it's an iron ore. It's called hematite, and it's an example. We assume that we have 10 holes. Let me show you. So this is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the cross section of 10 boreholes, and the borehole length is 100 feet, and after every 10 feet or 5 feet, let's say we calculate the core data. So this is when everything is done, and in the first hole we got 30 feet, 3 cores core we got of hematite, and then the second is 20 feet, the third one is 25 for 10 feet, 10 feet, 15 feet, 10 feet, 10 feet, and the last one is also 10 feet. So the green and yellow border is the ore body, hematite, iron ore, and this is the overburden. If we say like the first hole, we have 30 feet and the down 10 feet, so we have almost 60 feet overburden, and so you can see and calculate the overburden also. But how we gonna do to calculate the reserve estimation, how much reserves of iron ore we have? So let me show you on the other page. This is the calculation. So it's little bit mathematics and some type of chemistry. So here is a ore reserve estimation iron ore. So two types of, maybe other types also, but two types. Like the first one is hematite, Fe2O3, iron oxide. In simple language, iron oxide. The second one is magnetite. It's still iron oxide, but Fe3O4. The first one is oxygen 3 and the second one oxygen is 4. The first one is iron 2 and then the second one is iron is 3. Usually the color is dark gray, rusty red, yellow or purple. It's a geological terms when in the identification of iron ore minerals in the rock. Rock is actually aggregates of minerals. So that's two types. So I took the examples of hematite, and hematite specific gravity is from 4.9 to 5.4. And what I show you in the other slide at the beginning, let's say that the length 2800 feet up 10 hole in the cross section, width is 300 to 500 feet, and the height we take 100 feet each hole. So one thing in the mining, you can calculate the tonnage of each borehole. Let's say in the first one, which is 30 feet, and the second one is 20 feet. So it's usually cover the area, the influence of the area of the hole is 300 feet. So you can take it square, rectangle, or pentagon, polygon, and then you calculate the area and then multiply it by the height. So you got volume and then the tonnage factor. So you got how much tonnage of the hematite in that hole and how much overburden. So usually in the mining we start mining which called cut-off grade, where there is a good grade and less overburden. So along with development we produce little bit production like hematite ore also. So that's the mining economics. So hematite average height in the borehole is this is what I took the mean up 10 hole 30 20 25 10 10 15 10 10 10 10 feet divided by 10. So I got the average 15 feet. Usually in calculation we take the average, and if you see in this the most 10 10 10 10 10 10 is 6 time. So this is the most frequent number occurring like in the data. So it's a mean medium and it's other statistic thing. So so average height I got 15. Volume is of the whole area is 2800 multiplied by 300 into 15. This is the figure I make it. So if you want to see and check it, so this is the volume I got 1260000 feet cube. Tonnage factor is actually 200 pound is in per ton. There are 2 ton, one in kg, one in pound. So this is in pound. So tonnage factor is equal to 200 pound per ton divided by 5.4 is specific gravity of the hematite. 64.4 pound per feet cube is the density of the the water. So we got 5.7. I took 6. So total tonnage, iron ore tonnage is 126000. You can calculate on by using your computer or simple mobile or calculator. Divide by 6. So feet cube is gone. So we got 210000 ton or 2.1 million ton of iron hematite in this deposit. Did you know what I'm saying? So this is how you can calculate the whole tonnage average. You're gonna take the average height and then the volume, and this is where the 2.1 million ton is the hematite ore, economic ore you can mine from this deposit. This is what we have assumed. So this is how you can calculate and how you can use in the company everywhere. So I hope you got the idea, and this is once again are the holes if you want. So these are the hole, borehole, and this is the deposit within this. So shape is like this. So based on this, then we can do the mine planning, surface mining, our dumping site, our mineral processing plant, and in which block we gonna start mining. So it's the first one is 30 feet, 20 feet. So along with development, we do start mining. So I hope you got the idea and have a nice day. Thank you.